Well, ladies and gentlemen, we move into our next session on the topic Game Changers, Mega Trends That Will Rock the World. We have three speakers this afternoon. I'd like to request all of you to please give them a big round of applause as I invite them up on stage. Avneesh Agrawal, founder and CEO of Netradyne. Mr. Rohit Kapoor, Director Engineering, Qualcomm. And Sundara R. Nagalingam, Head Deep Learning Practice, NVIDIA. Please extend a warm welcome to all three of them. Each of them will be talking about the topic, and I'd like to hand over the mic to Avneesh Agrawal for his session. Over to you.
Hi, good afternoon. It's a pleasure to be here. So when you're an entrepreneur in the technology space, you want to ideally identify some key technology trends a little bit before others and bet on those. So when we started Netradyne around 3 years ago, towards the end of 2015, there was a couple of technology trends that were becoming quite visible to us and obviously a few other people as well. And those were, the smartphone revolution was in full swing. The cloud computing was the rage. And there was this algorithm called deep learning, which was essentially something that had been done for the almost last 40, 50 years called neural networks. They had been researched a lot, but there were some slight tweaks people were doing with vast amounts of computing and data. And the industry was beginning to notice that algorithm was sort of coming out of the research labs into the mainstream. And sort of what we thought about is, okay, why don't we just move the cloud computing to the edge, just move the cloud to the edge, and essentially start running these deep learning algorithms at the edge. Now, at that time, the level of compute power that you needed was pretty high, so it was a little early for that kind of bet. But what was a hypothesis at that point, I think is pretty much conventional wisdom at this point. I believe the era of edge computing, which is what we call a distributed cloud at that point, or cloud at the edge is now popularly known as edge computing, is pretty much conventional wisdom. So just for those, just to make sure we're using the same terminology, what I refer to edge computing is very simple. It's the intersection of mobile computing with the cloud. So you really move all the processing, not all, maybe most of the processing, the hardcore processing that you're doing at the cloud, you move it to the edge, and that's edge computing. Why do we believe that edge computing is going to be the force, the next wave of computing paradigm? One is it's a very highly scalable computing architecture. I mean, there are all kinds of prediction. Even the previous speaker was talking about the kind of predictions. For IoT, I don't know if 25 billion is the right number. It's 1 billion, 5 billion. I don't know the right number. But the point is it's a very, very large number. You start putting massive amounts of computing power and put the right software architecture in this, it gives a very, very significant and highly scalable computing architecture. But today's talk is not about that. I think there are people in the audience who can probably do a much, much better job than me in describing how this thing can scale up. The one thing that we found really exciting and we learned over time is that once you start putting computing at the edge, you actually get access to vast amounts of data. Because this is mostly video data, rich sensor data, and deep learning algorithms live on data. They thrive on data. So you start getting a secondary benefit, which becomes very, very significant, is you can start training your system and start collecting the kind of data which can actually create all kinds of new business opportunities and applications. There are applications in multiple industries. There are applications in automotive. There are applications in agriculture, manufacturing, healthcare. So I just want to talk about the application that we are very familiar with, is the application in the automotive sector, on how we're using edge computing to collect vast amounts of data. And in that process, we've actually created a secondary business, which actually I think is going to be much, much more significant than even our primary business. So what's our product? With Netradyne, what we're essentially developing is it's a vision-based driver safety system. We have a product, you can call it an intelligent dash cam, which has cameras, which has storage, which is fully connected with LTE. It has an inertial sensor unit. But most importantly, it has a deep learning processor inside it. It's taking all of that sensor data, both vision and sensors, and essentially crunching it. And what we are doing in our system is running the perception stack of an autonomous driving algorithm. We're analyzing every single object on the road. We're analyzing all the roads, the lanes, the road boundaries. We're reading 100 different kinds of signs. We're essentially mimicking human driver behavior. But unlike an autonomous driving system, which actually takes control, we are one step before that. We made a bet that for the next 10, 15 years, the world's still going to be dominated by human drivers. So can we leverage the same technology to improve human driving experience? And so essentially what we're doing is identifying unsafe events, capturing those videos around those events. We give a notification to the driver, but more importantly, we verify compliance of the driver. Did the driver behave responsibly in these different situations? We upload those videos to the cloud. We have a cloud portal. We have a driver app. And we essentially provide this full set of tools to insurance companies and commercial fleets. So that, in a nutshell, is our core application. The value proposition, the target markets are commercial fleets and insurance. And fundamentally, we are doing two things. We are measuring risk much, much more accurately because we are analyzing every second of driving accurately. And once you start measuring behavior, you can start modulating behavior. You can start creating incentives, carrots and stick to essentially improve. And I'm happy to say we've seen improvements, reduction in accident rates of almost 50% in many situations. So I want to just show some videos just to give you a sense of the kind of algorithms that are running at the edge on the device. And then I'll talk about what we do, how we collect all of the data, and what we do with all of that data. So this is an example where a driver, one of our customers, ran a traffic light. So we identify okay, it stopped playing. Excuse me? Can we go back? Previous slide. Can you play it? So here you would see the driver runs through a traffic light, and our system identifies, oh. It's stopping before. Let's move on to the next slide. Let's see if it persists. OK, before you go on, you'll just have to trust me. We identify it was a red light. We identify that the driver crossed the intersection when the light was red. And we captured those videos, and we notified the driver that please don't make that mistake again. But more importantly, we reported to the fleet and the insurance company. Go to the next slide. So this is showing that you're detecting actually signs. This is a rainy environment, so it's inclement weather. We detect signs, and we detect that the driver is actually overspeeding. These are valuable coaching opportunities because you can instruct the driver not to do this again. OK, I don't know what's going on with these videos. They're stopping. OK, I'll move on to the next slide. This is the inward sort of driver monitoring system where you're monitoring the driver looking for distraction. Hopefully, it'll play. OK, so that's, I mean, we couldn't play the videos to the full extent, but I think you get the picture of what's happening at the edge and how we're capturing the data. Now, what we're doing is when we're analyzing the scene, we are actually not sending the videos up. We're only sending very, very limited videos up. Only when the driver does something really, really serious, we're sending the video up. But what we are doing is we're representing the entire scene in textual format, essentially compressing that whole information into text and capturing up. And when I see the entire scene, which means every single vehicle on the road, your relative speeds, your relative distances, your angular speeds, the signs, the lanes, the road boundaries, everything is captured and uploaded to the cloud. That's a vast amounts of information. Just to get a sense of the scale we've already developed, we believe we have one of the most extensive vision-based driving data in the industry. Just in about over a year of launch, we've collected over 100 million miles of driving. We're doing close to 20 million miles a month right now. And if you look at the trajectory of that curve, it'll probably reach 1 billion miles very, very soon. And again, just to give you a context in this industry, getting this kind of real-world data is very, very difficult. For instance, Waymo, which is the leader in the autonomous driving stacks, is so far the entire real-world driving experience of Waymo is about 7 million miles, right? So the amount of data we're collecting through our system because of the business model of using commercial fleets is very, very extensive. How do we use this data? Let me give you one of the applications that we are now focused on, and we're actually getting a lot of success, is we can use this data to automatically generate maps. And actually, we can use this data to generate high-definition maps, which map every single object on the road to accuracy of almost 10 centimeters. These maps are a critical requirement for all autonomous vehicles, level 2 and up. And the other thing that's important is these maps need to be updated dynamically. So what's the alternative to creating these maps? The alternative to creating these maps is to get test vehicles, equip them with expensive LiDAR equipment, drive around. Estimates that it would cost you a couple of $1 billion to map the US once. It's pretty accurate, but it's about a couple of $1 billion. But if you map the region once and the region changes, what does an autonomous car do? These maps have to be updated very, very quickly, daily, hourly, as soon as possible. And it becomes cost prohibitive to do it using LiDAR-based equipment. This is where a system like ours, which uses vision-based edge processing, becomes very, very relevant. So how does it work? So the principle is very simple. It's kind of like stereoscopic vision. How does stereoscopic vision work? Stereoscopic vision works is when you look at the same scene from a slightly different angle, you combine it, you get a sense of depth. In our case, it's a single camera, but as one user drives by that scene, another user drives by that scene, the same user drives by that scene, third user, fourth user, right? You're essentially getting a look at the same scene from slightly different perturbations. So essentially, we have stereoscopic vision to the nth order. We can combine all of these different scenes, all of these different information that we've collected from all of the users. We can combine it together using localization techniques and essentially get an accurate 3D depth model of the driving environment. Our bandwidth requirements are very, very low. It's less than 100 kilobyte per mile. Because we're doing edge computing and translating all the important information and compressing it very highly, if you were to transmit videos up, you'll be essentially in multiple gigabytes per mile of data usage, maybe even tens of gigabytes. So this is an example where we did with one of our customers, a large auto OEM in Southern California. They were doing a head-to-head with a LiDAR-based equipment. So we just essentially took our map, mapped it onto Google Street View. So on the left-hand side, our vehicle drove by a region, and automatically a map got generated. The yellow lines are the lane lines, the red lines are the road boundaries, and you'll start seeing some objects as well, stop signs, fire hydrants, etc. It's supposed to be smooth. I don't know why the playback is like this, but so the whole idea is this map is being generated automatically. This is another example of what we're going to roll out very soon, is we're starting to detect construction signs and construction zone. So the whole idea is as a vehicle goes through a construction zone, the entire construction zone gets mapped, lanes get mapped, the rerouted information gets mapped, and that gets fed to autonomous cars. And in fact, our partner it's a large OEM developing autonomous cars, and so they can use that information. So what I think is happening is, in my mind, is fairly revolutionary. It's in the context of maps, but I think as edge computing starts percolating in different spaces, you'll start seeing the same kind of transformation. And when I say edge computing, I'm kind of implied at this point that it'll be edge computing with AI and deep learning algorithms. That's pretty much a given. Anything you do, you get access to data and you run your machine learning models in it. Until now, maps have been developed using the same mechanism. For thousands of years, the technology made it more efficient, but they were curated equipment with test drivers or test people walking around, taking data, and hand-curated a map was generated. I think what's happening now is with our system, is there are no site surveys, no specialized equipment, no human involvement at all. Highly accurate maps get developed. Essentially, a vehicle drives by a scene, the entire map of that scene gets developed. If the scene has changed, the entire dynamic change in the scene is represented. I think that's going to revolutionize the way maps are done. I think that's going to revolutionize the way autonomous cars will use this information, and so we are pretty excited about it. So this is, I hope My talk gave you some sense of the kind of applications that edge computing can open up, given the vast amounts of data at your exposure, at your will. I think this same applications in a different form can be across different industries, because I think edge computing just opens up a whole new set of opportunities for companies to exploit. Thanks.
Thank you very much indeed, Avneesh.